Hi, Nikolai. Welcome back.
Hey Adam, thanks for having me.
So I have to tell you what happened to me. So I wanted, to pick on YouTube, a nice chill music for coding with nice landscape, and I found actually a nice landscape with Creed. But it was nice the first 10 seconds. But then a crazy guy jump and talk about Java 19 all the time. So I try to mute it, but it is more like no, it was really nice landscape with Creed and beach and whatever, and then one was talking the entire time about Java 19. So what I thought about is maybe I should invite you back, because if Java 19 is even so popular on the beach, maybe we should talk about this, right?
Yeah, I love that reference. Yes, yeah, I thought it would be fun. It would be fun to have a video where usually I'm sitting in this very room. Which is it's an okay room, but it's still just a small room, so it doesn't make for the best scenery. So when I was in Crete on holiday, I was like, nah, I gotta take this opportunity. We gotta make a video here. It's just like it looks too great not to take the opportunity. And I think people liked it. It was a lot of fun.
Yeah,
I'm glad you enjoyed it too.
Yeah, but was it a lot of work to do this actually? I think so, right?
Well, so typically an episode takes me about a day or two to script, depending on how much I know the topic. And then it takes, like here in my room, I've got everything set up pretty quickly, so I can record in about an hour or two a video, which is usually between like 8 and 12 minutes long. But on the outside, it's a little more challenging, right? So you have to move stuff around. Didn't want to always be in the same scenery. You have to check, like, the wind was already a problem in the recordings, but actually it was, like, the better places. So there was, like, much worse wind in other places, so I had to check with that. So I think recording took, like, maybe half a day, maybe a little longer. And then editing was not done by me. That was done by my colleague, Billy. So basically I did, like, that's usually another 2 days. So I would say roughly I did half the work on Crete, and he did half the work in his office.
Okay, because you also changed location, so it was more challenging, right?
Yeah, exactly. Because otherwise it would have been, I don't know, it would have been a bit too boring. Because I was wandering around like the hotel. I was like, wow, there's lots of great opportunities to do a recording. I'm not sure which one to pick. And I said, let's pick all of them. Let's just move around. Let's have a different scene for each different topic.
Yeah, and you shoot it with iPhone or with what?
No, it's my actual camera. I took like a tripod, and I have a Lumix G7, which is a smaller camera. So like the Canons are a little bit larger. So this is a smaller camera, has a smaller chip and a smaller body. But it's our holiday camera anyway. So it's the same camera. So that's good.
Okay.
So that was that, and I had the mic with me, which did like an okay job given the wind.
Mm-hmm.
So yeah.
So so you took your Java 19 holiday camera with you. It's nice.
Exactly.
So people ask me all the time about Java 1. Will you actually attend Java 1? You personally?
Yeah. Yes, I personally will attend Java 1. This is my first Java 1 ever. Okay. So I'm really looking forward to that.
Very good. So we have scheduled an episode after that, so I can ask you questions, how it was, how was Las Vegas. As I know you will spend all the time in meetings and sessions and won't even see Las Vegas, but let's see, right? What happens.
Yeah, so actually I blocked a little bit. Like, actually, Java 1 is like, it's a long conference, right? But I managed to block almost a week in my calendar. Because, as I think I already told you, right? So when I have a wife and kid, and whenever, like, she works and travels as well. So whenever one of us travels, the other person basically becomes like the sole parent for a couple of days.
Yeah.
Which makes like everyday business just more complicated, right? Because we used to one of us bring her to school, the other one picking her up in the afternoon, stuff like that. But if you're like a solo parent for a week, you have to do all of that yourself, which just limits the amount of time that you have for, like regular work and going, just getting grocery shopping and everything.
So solo parent is singleton, right? For Java listeners here, right?
Exactly. Yeah, exactly. So the singleton parent, but just for a week. So for a couple of days. And that's why we usually try to keep this trips short. So usually when there's like an after conference event for speakers, like Java Zone does great things. I think JFocus as well. They're like go hiking and stuff. That's amazing. I've never done those because it feels like it's okay to be away for 4 days of work. It would feel weird to then say and also have to like go hiking for 3 days in Sweden while you're home alone. So I've never done this, but for Java's 1, I managed to like put an entire week aside. Because like I don't want to fly across the ocean for just the conference. I would like to have at least like a day or two to see something else. I mean, the States have It's a politically challenging country, or challenged country rather, but it's a nice country too, and nice landscape and nice things to see. So I hope to have the opportunity to see a little bit more than just Las Vegas.
Okay, so we should schedule an episode after Java 1, and I'm really curious about your opinions.
Let's do that.
So
you will not be there?
Not. I missed that. So I missed. But there are no call for papers, right? Are there? No.
No. So the thing with Java 1 is that it's like the first time in a long time that it's happened.
Okay.
And so we're basically starting this up on short notice, like running a huge, like I run my own conference. It's very small. You still need like half a year for a very small conference. For a huge one like this, basically like the big conferences, they go back to back. Like you run the one conference, you take a couple of weeks off, and then the work starts on the next one. And that was not the case here, just because like it was pretty late into that 1 year window that you need to for such a large conference that that we knew that we could start working on this again. And that's why it has all been on somewhat shorter notice. And so this year we'll be focusing on just getting the event out there.
Okay.
And then next year you can expect like the more regular like call for papers.
Okay.
Stuff.
So right now it's not Java 1, it's Java half, right? It's the official name.
Wow. Okay, let's call it Java 0.9. I'm
0.9. Okay. So now we have it. So just briefly, because you mentioned the conference and traveling, what happened to me once, I attended in 1 year. This was a community event, Sun in New York. Then in Las Vegas was the server side and Java 1. And because I had no time because of my regular projects, I spent the shortest possible amount of time on each conference this year. And the security people at the airport say, "What you did there?" So this was conference. So, but you spent just 1 day. It's impossible. No one does that. and they suspected me. They asked me whether I'm a criminal or whatever. And actually, it was pretty serious. I couldn't move out. So for unknown reasons, I was like, well, no, the pattern, what I did, just spending the least amount of time of conference, just picking and going home, was not what the AI back then liked, and semi trouble. So I couldn't book online flights. So your strategy is better, not to spend two weeks in Las Vegas or 1 week or whatever you're doing. But otherwise you become suspicious.
Yeah, no, that's true. Like in the past, my wife traveled even more, and she occasionally had issue with her credit card, so that payments would be declined. Because it cannot be the case that you have been like, I don't know, like in South Africa one day, and the next day you want to book something in Morocco.
No.
And then 2 days later, like in China, that doesn't happen. She's like, no, that's actually what I do for. I'm sorry, that's what I do for a living.
Okay.
And so credit cards would decline payment because they would trigger these what's anti-theft or anti-abuse law systems, whatever, so that they have in place to minimize the amount of money that gets funneled out of the credit card system by thieves.
So, but now back to the real topic. I wanted to say boring, but it's not boring at all. Java 19 and Java 19 is actually going to be a big release. And what's excited me the most is what I'm waiting for the longest, I would say, are the virtual threads, right? Which were called green threads back then, or were similar to the green threads. I don't know whether you know it, but at the beginning of Java we had green threads, and then everyone was really excited about the native threads. And there was even I don't know when it was, JDK 1.1 or 1.2. You could even switch between both depending on your hardware. Sometimes it was better to use green threads, and sometimes it was better to use the native threads. And now it's a full circle. Everyone is going or everyone is excited, me as well, to have green threads again, right?
Well, there's a critical difference there, though. So green threads were, you had a certain number of green threads, but they would all, like, there was a one-to-n relationship, meaning that, let's say you had 4 green threads and 2 actual operating system threads, then you would have 2 green threads on the one OS thread and 2 green threads on the other OS thread. So they could not change the OS thread they were ever running on. So always the same operating system thread would run the same green thread. And that's like when you talk about virtual threads for scalability, then that would be a serious problem, because that would mean you cannot just throw let's say like the Loom claim basically can just run 1 million threads, which is true, but it's also like it's not necessarily what everybody wants to do. But let's just pick that number because like it's a very extreme number. So let's say you run 1 million threads, but you only have underlying, I don't know, like 16 cores or whatever. So you will probably have 16 or maybe 32 operating system threads for running your 1 million threads. Now, if like every, what would that be, like 30,000 virtual threads would always have to be executed on the same actual operating system thread, and that would mean just one long-running task can lead to 29,999 other tasks starving. Potentially indefinitely, and that's not great for scalability, right? That would be a serious issue. So if you would have a few long running tasks, and a few in this scenario would be like a handful, they could block whatever, like a third of your other tasks out completely. So the assumption basically is that in a modern system you have like a mixture of more long running stuff and more shorter running stuff. You have a lot of stuff that waits a long time, because if you don't, then virtual threads won't improve anything. So you have a lot of stuff where you just go to the file system, which is like a couple of calls within Java, and then you're waiting for the file system. And so those very few steps within Java code, you want to take them as early and as fast as possible. And you don't want to be waiting for the long running whatever computation that sits in another green thread that on the same operating system thread. So that's a very important difference. But you're right. Like otherwise, they have the similarity. They have the similarity that they share same underlying thread.
So the more threads we get, the more problematic green threads would become, right? Because the likelihood is almost there then that one of the 30,000 threads will execute longer, and all others have to wait.
Yeah, exactly. I mean, that's at least my conjecture. I mean, that's definitely a computer science problem that surely somebody looked at and analyzed. But that at least would be my understanding that would probably be. I'm not leaning on that science, right? I'm just saying that it's my gut feeling that would be a problem. Yeah, exactly.
Yeah, and we could also get even deadlocks, right? Because if they are bound to one and the other waits on the others, and they both are waiting, there will be no resolution. So So I would say the virtual threads or Project Loom, there is no direct relation between the virtual thread and the actual thread, right?
Yeah, exactly. Like that's very important. I sometimes get questions like on Twitter. Somebody asked, like, what happens to the operating system thread? What do we know about the operating system thread? And my answer is, we don't care. Like, first of all, like there's a strong barrier between it. I don't know 100%, but I think it's not even possible to get any information about the operating system thread from within the Java code that runs in a virtual thread. Well, probably there is some. There might be some MX bean, whatever, that you can get some information. But like regular APIs, like if you ask the thread, what ID do I have, and what's the current thread, all of that things. If you run a virtual thread and you ask a thread API about anything, it will only give you the virtual thread information. You will not be able, to my understanding, to get through to the underlying operating system thread and get any information about that. Which is as it should be. I mean, it's interesting to think about how this works, and the mounting of a virtual thread on an operating system thread, and the unmounting when it waits and all that. And that's very it's technically interesting, and it makes sense to talk about that to get a better understanding. But ultimately, that's very much an implementation detail that we should not care about. Just like we don't care about how the operating system swaps memory pages in and out, we should not care about this really. Like, it's fun to talk about, but we should dig that deep. It doesn't matter. Ideally, we would never need to know about that, and so we just ignore what exactly is going on within our virtual threads. So we can really just think of them as just regular threads, just we can have more of them.
Mm-hmm. The question is, why not switch completely to Project Loom always, right? So we could actually...
yeah, sure. So that's I think that's entirely feasible. So my understanding is that the scalability benefits that Loom promises you, they only occur for certain projects under certain circumstances, right? So they only happen if you wait a lot. Like if you keep your CPUs busy, you won't benefit from virtual threads. But also, to my understanding, the overhead is pretty minimal. So my understanding would be that it's probably easier to just, like, I'm writing a web backend, I'm gonna go with virtual threads. Period. That's, once again, I don't want to give this recommendation because I think it takes some time to maybe check out some details and see where that actually works. But my guess is that this will just become the default, and there will be specific workloads where you decide on purpose not to do that. Just like you get, I don't know, G1, GC by default, which works better for web backends because it minimizes pause times, but has overall a higher resource consumption, where it's a good default because most Java code runs in backends, But for the few where it doesn't, not the few, but for the ones where it doesn't, for all the other use cases where you have a desktop application or you have just a batch processing system or whatever, or just a service that you call like for long running tasks, all of those things, you're like, you know what? Actually, I don't care about latency that much. I do care about just raw resource usage. So I want to use parallel GC because it can give me like 3-second long pause times, but I don't care. All I care about is they have a minimum amount of overhead in total. So then I switch the GC. And I think probably that could be the case with threads as well, that you have very specific cases where okay, in this case, like all the Loom thing doesn't make any sense at all. I'll just go with operating system threads. But I would guess that virtual threads will become a reasonable default. I don't think, that's a default, of course, that then the web servers would have to pick. It's not something that the Java code, like the JDK cannot make one of these threads the default. Like it depends on which API you use, which kind of threads you get, and that will not change. So the question is, what APIs will people and frameworks and servers use by default? And my guess is many of them will probably switch to virtual threads over the next years. We're talking about a long time here, right?
Yeah, my guess is earlier, because what happens is, in my project at least, and with my project and more boring enterprise projects, is that the high performance projects are become less and less important, because what you tend to do is to move away from dedicated hardware to virtualized environment, so you cannot rely on the absolute power or performance anymore. So you have to work on Kubernetes or Docker, whatever, and in multiple virtual machines or AWS Lambdas or serverless or Oracle functions or whatever. So, and there's short-lived processes. So even, the garbage collection tricks became less and less important. So we usually ship with the default settings and rely on Java ergonomics, which works good enough now, but it didn't work, even 5 years ago good enough. So I would say 5 years ago, I still, or maybe 7 years ago, I still got a lot of requests, helping my clients with performance issues, and now it become less and less important because the landscape changed, and therefore and Loom, why I'm excited about is what I really don't like, what's I would say, how to call it, maybe artificial usage of reactive programming, right? So this is what I saw in lots of projects that just used the reactive programming just because they could. There was no real reason, and this introduced some complexity, and the argumentation was always, one day we will have to scale more, and with reactive programming we can achieve that. And with Project Loom, I could actually ignore all the reactive programming APIs and even JDK 1.9 reactive programming APIs, and just just write old-fashioned Java code. And if there is more traffic, maybe I'm not running, in the highest possible performance, but at least won't break. And this is what I like. So we can still write really simple code, boring code, without thinking about high scalability too much. So this is my huge. This is why I'm really so excited about Loom.
Yeah, I think the situation you described where people use reactive that way, that's like. That in that situation you have a lot of forces on that system. So first of all, you're you're under the assumption that, and that's probably true, that if you do want to write a highly scalable system, you could not do that with just regular boring Java code. You would then in that situation have to be reactive. And then, well, we're not there yet, right? So that project was not there yet. And most projects will never get there because most projects, turns out, don't need millions of connections a second or whatever. But then, of course, but if you see a reasonable future where that could happen, it would also suck if you then arrive there and you're okay, now we basically have to, start writing stuff from scratch, because you cannot just dump your old business log that uses blocking calls everywhere and throw it into a reactive container and it just magically works, right? Actually, Loom mostly does that, which is the amazing part. But with reactive theory, then I have to rewrite a lot of stuff. So of course I understand also the other situation, the other position of being but we want to be there. We see a path to that future where we need that scalability. It would kind of suck to rewrite everything then. We can just pay that, extra cost of writing somewhat unfamiliar code now. But then again, also some people I know, they just like writing they like using those APIs. They like writing or thinking rather in their reactive pattern. And for them, it's not even a downside maybe, right? So I think all of these forces probably work on these projects. And it's not trivial, I think, to decide. But I would definitely agree with you to err on the side of, you know what, let's just write like this simple, boring Java code that doesn't maybe use like the fancy new a library or framework, but still, and then still have the option, or rather have a situation where it will scale. And the question how well it scales compared to reactive, that's actually quite interesting. And I'm sure we'll see like what actually somebody has to do is to take like a dozen highly scalable systems and write them both ways and then see what performs better, right? That's like the only way to get a somewhat scientific answer to which works better when. This is not going to happen. This is just so much time that nobody is going to invest. So it will basically be more anecdotally, anecdotes, whatever, like, you know what I mean, right? So
anecdotal,
right, anecdotal. So it's like, because like you just can't do that. But like some preliminary tests that Elliot Ballas, for example, did, he wrote like he wrote like a small server in reactive, and I think he also used just like non-blocking IO, and then also Loom, if I recall correctly. He did some experiments, and really looks like in those specific experiments, right? So I'm just like, and it's also an artificial experiment. It's not like all experiments are, but it's not like a real code base. It's just an experiment. What you could see is that Loom performs as well as reactive, but in that situation took a little bit more memory, if I remember correctly. So it's not even necessarily the case that reactive gives you like Loom only gives you like 90%. That really depends, I think, on the details of the application. And I have no idea what those details are, and it would take time to figure out what details make maybe reactive be a couple percent better or make Loom be a couple percent better. But I'm questioning whether that will really ever figure it out in that detail, because as I said, that would mean like to really be rigorous
but
about
you know,
it, you have to compare the same thing.
No one cares about the 5 or 10% even. Let's say reactive programming.
I wouldn't say no one.
No,
very
course.
few.
No,
Yeah.
but I would say if I'm in charge in a project, and someone will come to me and say, look, we have to use proprietary APIs in order to be 10% more efficient. Then the question is really, they may be, if you're building a gaming server or even not a gaming server, let's say you're building an ingress controller for a cloud. This makes sense because 10%, whatever you're doing, it is worth of doing this. Or you have millions per second messaging app. But I'm talking about enterprise projects. Then using and strange API and believing that all developers will learn it and love it and maintain it over the years is just never pays off. So I would say I will always start with the simplest possible, more natural thing in Java. So write simple code and hope that the platform will just resolve the issue. And we had similar conversations back then, of developers wanted to write pools to improve performance and cache strings and write strange code. And what they introduced often was memory leaks and just simple code was better than sophisticated code. And my feeling is this happens the same in the project Loom. So it will be good enough for 90% of all cases, and you will always find cases where the general approach is not good enough. But this is always like it is, right?
Yeah.
So, yeah.
Yeah, and there, as I said, like I just want to repeat that point. I'm not even sure whether it will turn out that that in the extreme case you have to go reactive. I'm not even sure that's settled. But yes, otherwise I agree with you. I mean, I think what it comes down to is the cost that an app incurs for operations and for development. And we think of DevOps at the same as like one unit, and that makes sense from any perspective. But if you just look at the cost, like how much do you pay developers and how much do you pay cloud provider, like to oversimplify it. And I think that's an important distinction in where does it make sense to save money. So, for example, like I was always impressed that organizations like companies like Twitter, for example, I'm not sure about Netflix, but like these large companies, right, that they have JVM engineers. They have people on staff that dig around the JVM, try to understanding better, making improvements, applying patches, hunting down, performance problems. And that's ridiculous, right? Because those people are very, very far removed from benefiting the company directly, right? They're people you hire, which are usually highly qualified and thus, I assume, highly paid, to working on the platform that you're using to deliver 280 characters. But the point is, you can afford to have a bunch of those, dig into the JVM, because if all they do is give you like a 1% performance improvement year over year, that will still pay off at that scale. And that's something that a situation that very few companies are in, that they're running at a scale where the cost of operation dwarfs the costs of development by so much that it makes sense to have like, okay, let's invest in, let's say, 10 or 20% more into development to save like 1% or 2% on in operation costs. And most, like specifically enterprise applications you describe, I would guess are probably not in that situation.
No.
And if the cost of development dominates, then yeah, sure, write the code that everybody understands and can debug and can fix a mistake, and that you don't need like a 3-year mid-level to senior education program for new people coming on board, but you can just hire, like a regular run-of-the-mill Java developer with a couple years experience, put them to your code base, and and they roughly know what's where and how things work.
The problem is that the Twitter engineers join, or go to Java 0.9 conference, for instance, right, and talk about their inventions, and then the board enterprise developers listen to them and say, look, we have the same problems as Twitter has, and they are introducing the reactive programming just because they are bored with the simple code. I see it over and over again. No kidding. We had a discussion already. One of the most frequent questions before the project even starts is, what's in my opinion about Kotlin or Scala? Less so now, but Kotlin. And I say, okay, but we don't even know what we are going to build. Maybe just plain Java 17 is good enough. And I'm not sure whether Kotlin will help us that much. Yeah, but it's nicer. And then structured concurrency and whatever. I was like, but. We are boring enterprise projects. Maybe we get, if we are lucky, 2 transactions per second, right? And then hope that there will be enough load, to see, the multi-threading even. And you are talking about reactive programming. But what Loom also introduced is structured concurrency. So this is not just about threads. There will be a class called StructuredTaskScope, I think, structured task, which help us, to deal with the concurrency, right?
Yeah. So yeah, exactly. So maybe let's take a step back for a second. So we're talking about what changes are in Java 19.
Yeah.
And we've already just talked about the virtual threads, which is one JEB. Let me look up the number. It's JDK enhancement proposal. That's what JEB stands for. 425. That's on virtual threads, and that gives you. What we didn't technically explain how it works, but like the summary is, have as many threads as you want. Thousands, tens of thousands, hundreds of thousands, maybe even millions. Just go ham. Go take virtual threads and go and, get as many as you want.
Do you know the performance implication? Let's say between 1 million and 10 million. Is there any difference?
Well, there's no general thing. It depends on what they do. Like if you write the stupidest code where you just create 1 million threads that sleep a second.
Yeah.
Like on a consumer laptop, I can create 1 million virtual threads that each sleep a second, and that program runs in 1 second plus, like super low overhead. So basically what it does, it creates like it creates a virtual thread that uses the operating system thread, then that goes to sleep, so immediately the operating system thread can do something else, and then I create the next one. So you can create 1 million of those in almost no time. I don't know. 90% at least of the runtime of that system is just to wait. But of course, that's a stupid example, right? Because you're not actually doing anything. So so virtual threads have very low overhead, but whether they make sense depend on how much waiting there actually is.
But RAM overhead, is there a RAM overhead? It has to be.
Yeah. I mean, again, that depends on the depth of the stack. Yeah. So you have a call stack that has to go somewhere. Usually the call stack is, you have a bunch of threads, let's say, 32, for example. You have 32 call stacks, and they're all the time, they're shuffled around, and that's fine, that's good. But if you have millions of them, you constantly have to, park the call stack somewhere. And then that depends on what your call stack is. So in my situation, my specific example, what I did is I said basically create a new thread and then sleep for a second. That is like a super small call stack, right? So having 1 million of those is basically free. It's like 1 million. I know what a call stack is. It's like a linked list essentially, right? There were no variables on there, so it's like super small. It's like 1 million small lists to have. You can have
1 million instances, 1 million Java objects, right? So this is what.
But in each of those is like a small linked list, probably something. I'm not sure how exactly it's implemented, but that's technically what a call stack is. So, it's a stack, but that's anyway. But the point is, if you have deep call stacks, so for example, if you want to, if you batter your your web framework with 1,000,000 requests per second, and they go through like the whole Spring layer of like a gazillion like verification and all kinds of checks, and then they end up like, I don't know, 50 calls deep in your before they touch your they touch your code, and then you do a couple more things, and then they go to sleep. Now you have like pretty large stacks, and then surely you will start to notice that in memory. Yes, exactly.
Okay. So so this was just the virtual threads, and there we have 428 JEP.
Exactly.
And this is the structured concurrency. This is more exciting because we get new classes.
Is that the hierarchy? More classes, more better?
No, more exciting. It's not better. It's just something new.
Oh, right.
Yeah.
True.
Yeah. Exciting is out of question. I would say whether it is good is the different one. But we get a new class is always exciting in Java, right?
Yeah. No, that's true. That's actually the thing. Like what I enjoy most is probably like language changes. The next one, I have also an exciting hierarchy, definitely. The next one is like new classes, as you say. And like virtual threads are actually very like the category where virtual threads belong in, which is something changed within the JVM, is actually, or within the JDK, is actually pretty low on my list of exciting things. It's like, okay, that happens like all the time. All the time something in the JDK changes, and then something, changes behavior a bit. But Loom changes behavior so much that virtual threads are still very exciting. But you're right. So virtual threads, structured concurrency, that's and the idea here is, okay, so let me first explain the idea of structured concurrency, and then we go back why this happens in the context of Loom. So the idea behind structured programming was, back in the days, I don't know when, I want to guess 60s or something, but I'm not sure. Definitely before my time. Was that having just like basically infinitely long list of commands that's supposed to be executed, and then jump across this list or this sea of commands with gotos, is probably not a great idea to write code that's supposed to be maintainable. Because it turns out, well, that's like probably the most efficient and also like the most straightforward way you can write something. This becomes like unintelligible very, very quickly. And as program size grew, this meant that you always have to have the entire program in your head. You have to like simulate the entire thing to understand where the control flow goes. Simulate in your head, right? To understand where the control flow goes, because there were like no boundaries at all. And structured programming was taking away some freedom. It was like, you know what? Maybe we don't need to go to... Yeah, exactly. Don't go to everywhere all the time. Maybe just have like ifs and loops. And then actually like back then there was like a big pushback. And they'll be like, no, you cannot do everything with this. And then there's a famous proof in computer science, which is so famous I forgot the name, which actually proved that no, you only need, like if you have something like if and loop, and I'm not sure whether you even need more. If you have like a couple of these control structures, you can actually replace, like you have the same expressive power as with goto. Because initially people were like, no, but how can you do this without goto? Well, then you figure it out. You mean way.
Turing complete, right? So that you can express whatever is possible. Is it this? But by the way, goto. This was my first smart pants, tasks where I saw goto. It's like, no, you shouldn't use goto. Use go sub. I said, go sub, because goto, you have to remember where it came from, and go sub, you jump somewhere, and then if you are done, then it jump back. This was go sub. This was I didn't know that.
Yeah. So what's the command? What's the command to jump back? Like, is there? So go sub is go somewhere, and then when that block is
this
over,
was basic. This was basic. 10 years ago. No kidding. But go to, and then you have to go to back, and go sub. Okay. You just went somewhere and then came back. So it was like a small function already.
Yeah, kind of, right? So structured programming was about introducing those. Actually, now I'm wondering, like maybe I switch this up. Was structured programming about the if and the loops? Anyway, so what it also was...
Yeah, structured programming, you're right. This was C, actually. Structured programming, they were like, in German, I forgot the English term, but in German was Struktogramm. It's like, Struktogramm was like the strange thing. If was like a triangle with if else.
Yeah, exactly. Yeah. Exactly. I remember those as well. It's a way basically of like visualizing a program. And the loop was like an inverted L or something, right?
Yeah, it was terrible. Yeah. You could do maybe a hello world, and then I always mess up because there's not enough room, on the paper to refactor.
Yeah, exactly. So the other part, an important part of structured programming was to have procedures or functions or methods, or whatever we call them, So blocks of code that have a single entry point and then either a single exit point or at least just clearly defined exit points. So the idea was, let's create a block or a scope where we know that all that happens within that scope only, right? So we know like whatever this method does or this procedure does, it does it in here, and it doesn't just randomly like gets go-to'd into, and it just doesn't randomly just go to out where it never comes back. So structured programming is, again, it's a limitation, and it's saying, look, let's not do everything we can. Let's just stick to a limited amount of how we would call that. Let's just limit our freedom to just do fewer things, or to be allowed fewer things, but then that gives us a structure that makes it easier to understand programs. Okay, so, and that is basically the idea of structured concurrency, but for concurrency. So concurrency is similar to this go-to world at the moment, because you start threads wherever you want, you have no idea where they complete, like it's all just like all over the place. So so the similarity to GoTos is that if you want to understand how concurrency works in the system, you again have to mentally simulate a large part of the system to understand where like something gets created, in which thread or which thread pool, and then how long that goes, and where you get the results back and all of that. And so structured concurrency, and this is not something that the Project Loom folks came up with. I will, the next time you say something, I will quickly look up the name of the people who popularized this, because it is in the JEB somewhere. So this was not based on the ideas of the team. This is an idea that has been around longer, but JEB 428 wants to bring that into Java. So the idea is you're not just creating, I mean, you can still do that, right? It's not like nothing is taken away from you. You can still use all the thread pools, and you can still use like thread run and whatever, or thread start, I think it is. So you can still do all of that if you want to. But additionally, you get a new API that forces a more structured approach. And the idea here is that you create what's called a structured task scope. And you do that in a try with resources block. So you create this new scope for tasks in a try with resources block. So try, and then you open parentheses and you say scope is new structured task scope. And then within the try block, you will say, okay, do this task, do that task, do that task, whatever. Like ask that weather service, ask the fallback weather service, and then also, I don't know, like query something in the database that we need to charge the user, whatever. Like do these three things. They happen then concurrently. And once you're done, you will just, so once you fired these three off, maybe you do some other computation, whatever, maybe you keep yourself busy, but at some point you want to wait for them. And that happens in the same block. Like that's the same block of code. So if you want to do longer things, you would put them into your own method, call that method, because you want to keep that block of code, short-ish, like you always want to keep blocks of code. And so when the try block ends, the scope gets shut down. And at that point, you have to be done. So the idea is you create all your tasks in one scope at once. And when the scope is done, you're done with those. So when you start a new thread, it will end in the same scope. That's what structured concurrency is about. And that has a bunch of prerequisites and consequences. One of the prerequisites is, if you don't want to somehow like manage global state or want to always hand around the same task code or whatever, like it's really, really helpful if you can just create new threads everywhere. Like in this situation, I just said like I want to have new 3 tasks. It would be by far the easiest approach to just create 3 new threads for these 3 new tasks and wait for them to be finished, and not do something like thread pooling or whatever, because then you have to share the same thread pool, blah, blah, blah. No, you just want to, everywhere in your code where you feel like I have to do concurrent tasks, you just want to start new threads to run those concurrent tasks. Now, that does not work well with operating system threads. You cannot just have, like in a modern Java system, every piece of code just be like, yeah, sure, I'll spin up a new operating system thread. That will be fine. No, because then you're running out of OS threads. You want to manage those, hence the pooling, blah, blah, blah. With virtual threads, you don't have that situation. So that's very great. That's great. You're in a very good situation with virtual threads where you can just create new ones wherever you want. So that's a prerequisite.
Actually,
that's why they two belong together.
If you think about this, the Project Loom is actually a huge thread pool, right? This is a global singleton thread pool, so you can pick and threads whatever you like, because they are maintained by the JVM, so it maintains all the virtual threads, and they are somehow mapped to the real threads. But actually, I would consider from the conceptual perspective the Project Loom as a huge thread pool.
Yeah. So let's take that sidetrack, because that's very interesting, and it also works in a way very much like reactive. So if I tell you I have a system where when you make a certain call, what happens under the hood is that call does get executed, but then because it requires some waiting, we basically register a callback, and then we go do something else. And when the callback completes, we're going to continue with the computation. What did I just describe? Because that's also how reactive system works, right?
Yeah.
They like this async IO for example, where you just only use the thread to do something when you're busy, and when you're waiting, you register callback, so you don't actually have to actively wait. And that's also what Loom implements under the hood, right? So that's
the cool story is that the reactive system is the exact opposite of Loom, because they are usually just using one thread, right? So the entire event system is in one thread, and then sometimes they use a different threads for the actual work, but the event loop, like Node.js or whatever, it is always one thread, right? And in Project Loom, we have infinite amount of threads, which is interesting, because why it is so interesting, what my observation in general is, if there is a best practice or a pattern, if you take the exact opposite, you get another best practice, right? And it seems to me like the reactive programming with one thread and programming model, and Project Loom without a programming model, or almost, forget structured concurrency for a second, and an infinite amount of threads. They are both best practices or both patterns, but they are exact opposite. Project Loom, no API, infinite amount of threads. Reactive programming, strict API, one thread.
Yeah, so I would have to think about that a little more, and I feel like you're right, but that also only discusses the part that's exposed to the user, right? So
yeah, sure.
When you just said that Loom works like when you just said that Loom works like a giant thread pool under the hood, then that's true. And I also think that the way that Loom does those the virtual threads are using those async APIs where they're available. Under the hood also has similarities to how that works generally in asynchronous programming.
Yeah, sure. Yes.
So what it does is it takes those working concepts and abstracts them, so you don't have to write more complicated code than you want to benefit from them. You can just write like the regular blocking code. Yeah, so that's definitely that's the global thread pool and the global async thread pool that we have there. Okay, so let's close that sidetrack. Let's go back to structured concurrency. So you want to be able to create all of these threads, and we just covered that you can do that.
Another interruption. Yeah. Sorry. The structured, it is our podcast. This is usual. But the structured task scope, I think, is the name. Is this like just pure JVM structure, or is this somehow native? You know it? You know what I mean? Is it just like invention, like let's say a Java record where you can just group things, or is it like bound to the operating system somehow? So how low level is it, the structured? Because I look at the source code, and for me, what I'm thinking about, is it just a convenience grouping of threads, or is this something more behind where it is bound to the low level mechanics of JVM?
Yeah. So the question, you can rephrase that question as, could I have written that code,
exactly.
Or does it have to be in the JVM?
Very good. You are evangelist. I'm just developer. Now you see. This is.
Yeah, but that's I come to that. I rephrase it like that because it's actually a question that the JDK. That's one interesting. Or one important question that the JDK maintainers ask when it's about, can this be in the JDK? So often people come like, hey, I have this great usability method. Could this be in the JDK? Mm-hmm. And then like one important test, it's not the only one, but one important test is, does it have to be? Like, is there benefit when it's in the JDK? Or could it just as well be outside the JDK? Mm-hmm. And I think that's like an interesting thing because that's what Java, like for example, Java on purpose doesn't take on like any machine learning specific stuff in API because it feels like we don't have to. Like this is great to live outside in libraries and other projects that can, like experiment and evolve more and faster than we can. There's no point in us dragging this into the JDK. So what about the structured task scope? That actually deals with one of the big advantages of a structured concurrency as it appears in Java now. So when you do what I just described, you open a new task scope, and then you create 3 new tasks that you want to run. Now let's say something goes wrong, you take a heap dump, or you just look into the debugger. And what you usually see with thread pooling or with reactive is you just see like 3 tasks together with all the other places where you run tasks. So you just see like 100 tasks that are currently being run, and it's super tough. Specifically without extra tooling, to figure out like where do these come from? Like this specific task, what was the web request that spawned this? Like what triggered this specific let's say, database request.
The correlation
happens
ID,
to
right?
run.
So usually we talk about correlation ID, how the user
Exactly.
request is bound to the threads and
Yeah,
to
you
the
have to
process.
put in exactly. You have to put in like more information to track that, and it's not standardized by tools, so it's not like an easy click in your IDE. So the thing is this: what the structured task scope will do is something that works only if you have so many threads, and that is, a thread will basically get the ID of its parent thread. So when you create a structured task scope, you're creating a hierarchical situation where you're saying, look, I'm running this code in one thread, and what I'm doing now is I'm creating 3 new tasks. These are subtasks. There's a hierarchical relationship here. I'm a task. I'm running something big. I create these 3 new small tasks, and where they are done, I can continue. So you can think of this as a tree, where you have like a request comes in, and it can spawn 1 or more subtasks, and they can create more subtasks. You get like a small tree of tasks that is being computed to finish that overall request. And what the structure concurrency APIs, this is the first one that we have, and it's maybe we'll see more in the future. What they do is they put that relationship into the virtual thread. So a virtual thread knows which parent virtual thread it belongs to. And that's something that you cannot do from outside the JDK. That's why this must be part of the JDK API. And that is great, because what that means is, let's say you put a breakpoint at some place in your code, and you're running one of these subtasks that in a regular world would just be like a small thing that would be running in a thread pool. And you know that problem, right? You go up with call stack and like, crap, I'm sitting in like, whatever whatever thread pool I have in its launch or start or whatever method that triggered this specific thread execution. Now, how do I find the parent? And that would not be the case. Like with structured concurrency and virtual threads, your IDE has all the information it needs to give you a little button where you say, let's just jump to the parent. So you're sitting in your database task with a breakpoint, wondering why you got here. You open the debugger, it will show you the call stack, and then somewhere your IDE, it has all the information it needs to connect that to the parent thread. So you could just click a button, go to the parent thread, and then you're sitting, where's the parent thread sitting? Okay, I know where it's sitting. It just fired off the database request and maybe through other requests. So it's sitting at this close call on this task scope, waiting for these to complete. But now you're in your parent thread, so you are in your parent's call stack. So you can see, what is the information there? What is the variables that are on that stack in other stack frames, and you can go all the way up to the request this way, and you can go back down as well. So you have like this new relationship here, and this will be somewhat challenging for IDE developers to deal with, because at the moment you have like a drop-down box to select your current thread in most IDEs. That works great for a couple dozen. That doesn't work great for a couple 100,000. So they have to find a new way to let you pick what thread you want to look at. First of all, a drop-down list that populates with all the threads that it can find will give you like a super small scroll bar and like basically, by human standards, infinite amount of threads to scroll through. So that's not helpful. And then also, like, it doesn't show relationships. So there's like room there to do cool new things to help developers better understand the application. For example, what I like is like the IntelliJ stream debugger that they have, where you can run a stream pipeline, it observes it, and then it basically gives you like, it's not a marble diagram exactly, but it gives you like more information about which elements got filtered and what happened with that map and all of that.
So let's rephrase that. So what it means to me is, my code is always running in a thread. So if I start with a structured scoped task, this is the right name, as I forgot.
Structured task scope.
Let's just call it a
scope. Yeah.
A structured task scope.
Yeah.
Then, of course, it is going to be executed in the scope of the first thread. If I start another task inside this scope task, then what happens on the bytecode level is similar what happened, a few years ago. We had thread groups in Java. So in Java. So what it meant, I could have multiple threads in one group, and this this does is it say, okay, everything which is started inside the task scope, the thread prior to this become the parent. So on the bytecode level, it's just the association between the subthreads and the parent thread. This is what happens on the bytecode level. Exactly, right?
So it's basically just a thread ID that gets written to a field somewhere that then is stored. Exactly. Yeah. So like the idea is that, so the implementation. Well, Okay, so the abstract version of the implementation
Yeah, sure.
is pretty simple.
Yeah,
You
it's
just
just
plug a thread
concept.
ID into a field somewhere.
Yeah.
But that only works because you know that these tasks will only, or these new virtual threads are bound, their lifetime is bound in a larger scope. So this would not work if one thread, let's say thread A, triggers thread B and then keeps going, and then thread A ends and B is still running around somewhere. Then it wouldn't make sense for B to claim A as my parent. That
Interesting.
only makes sense if A starts B, C, and D, and we know that A waits for B, C, and D to complete before it continues. And that's exactly what structured concurrency wants you to do with this try block, right?
Yeah.
You start new tasks in a scope, and you wait for them to complete in a scope. And one advantage you get for that is this hierarchical relationship that you are creating gets explicitly written out into the fields, into the bytecode, as you said, and then they can be picked up by other tooling. So that's one very important consequence of this. And this will once we do all this, I think it will be unthinkable for how it was before. Like, imagine now debugging without being able to just randomly click into your call stack to drop frames, to start over. Like, this is really crucial for when you're debugging code.
Yeah.
And
another analogy, I guess in your leisure you are reading EJB books like crazy, Enterprise Java Beans, and
all day long.
and they had transactions, and one of the so I have a streaming show called Airhacks TV, and there's one very common question, as it was at least, was like nested transactions. So there was always the question: we have one transaction and in one method. And in the sub-methods, there are transactions which are just independently started. So imagine...
So help the EJB noob. Are you talking about database transactions or what kinds of transactions?
The cool story is EJB was just a virtual transaction. And in one point of time, it was mapped to database or JMS or whatever. But at the conceptual level, the transactions were actually bound to threads, which is very similar. This is where I'm going to. Okay. And the interesting part is, if you imagine a web app, so... if you called, and this is now exactly true with Helidon or Quarkus, we can use transactional annotation, which behaves identical to EJB. But so if you have an entry point to an application, a boundary, and this is like JAX REST, so just REST endpoint, and then you put requires new transaction on it. So what it means is the method is going to, the transaction is going to be to start at the method begin, and commit or rollbacks at the method end. So and now the question was, if we start inside the method new transactions, so we go to a database or to GMS, new transaction is going to be started. Is it possible? And the expectations of developers is that if the outer transaction rollbacks, the inner transactions also have to roll back, which is impossible because they are independent. So what it means is exactly the same problem you said right now with threads. We had the problem with transactions is identical. So with structured concurrency, I could get structured transactions, which is let's say so then I could start a sub transaction. The parent would be the super transaction, and then everything would be rolled back or committed, which was not possible before.
Okay, so if I understand you correctly, in general, there was no guarantee that the outer transaction, the first transaction, would still be waiting for the inner transaction.
Yeah,
so
it never waited. It never waited. It was asynchronous. It could never wait because it would be ridiculous.
Okay. That's okay. That makes sense why you cannot roll back exactly, because the outer transaction might already be done. It might.
I forgot to mention if this is of course the question was always in an asynchronous transaction. So the first one was synchronous and it was asynchronous, and my answer was always I forgot to mention this, of course. So in the GMS case, if the inner transaction runs longer than the outer, which can happen, then is in no way that the outer can know, 5 minutes, this is mission impossible. And then say, okay, you are right, actually. But with a structured concurrency, structured transactions, this is what you're saying. It solves actually the problem because it will know, okay, the under transactions know the parent transaction, and there's the relation. But in the EJB transaction, there was no relations. Which if you explain that, I immediately thought about the problem. This is a phenomenon with transactions. And funny enough, it is actually stated that in this spec called JTA, Java Transaction API, the transactions are actually bound to threads. So what could happen is, with Loom, that it can have some impact on enterprise actually. So maybe we get no structured transactions, because if transactions are threads and they can communicate easier with each other, so who knows, right? So it could be interesting stuff can happen actually.
Yeah, but then I'm wondering about because you described that these transactions are asynchronous, if that's on purpose. Like if you're
this was on purpose, but if it's not on purpose, so at least I could start one transaction and everything is synchronous. Then I could say, okay, the transaction is propagated to all threads. At least this would be solved with StructuredTaskScope, because right now, if I have transaction and I'm using a thread pools, and also they are no synchronous, the transaction context can get lost. But with Loom and structured concurrency, I could keep the context going. So regardless how many threads am I starting, if I'm waiting for all these threads to complete, I can still have one common transaction to complete or not to complete, which is exciting.
Yeah, exactly. And it really depends on because, as I said, like with StructuredTaskScope, you create this hierarchy of one task belongs to the other task. Mm-hmm. I mean, that does not cover all tasks, though, right? Sometimes you just have something where, okay, so we're completing this business. Let's say we're completing this business operation. What we now need to do is, I don't know, we need to trigger, I don't know, something else.
A very common example is you're writing, you do something, and regardless whether it was successful or not, you have to write audit to a database in a new transaction, for instance, right? So this is a typical, or not typical, this is one of the cases in enterprise, where you do something, and regardless whether it's successful or not, you have to write to a database. Now you have the problem, because if you do everything in one transaction, right, and if the first part becomes unsuccessful, the entire transaction gets rolled back, and nothing is written to the rollback, to the audit log. And what you would like to see is, on error, you are writing the error to the log. So you will need, back then, two transactions, which are independent, and now we can maybe have something more simple. I have to think about, but...
but if it's something you need to do, then I think it still fits into this hierarchical model. What I'm trying to come up with is an example where you don't care. Like when you say, look, my task is done. I really want to fire something off that happens in the background, but that's unrelated really to me. So not everything fits, of course, into this hierarchical model. There will still be like background tasks that you have to fire off that you do not want to wait for. And of course, that works. You can still use a virtual thread for that. You just wouldn't use a structured task scope. So it's not like virtual threads force you to use structured concurrency.
No.
It will I think it will be the main approach. And as you describe, I think that can work well beyond just this specific API. The benefit can probably also be reaped by other frameworks or other approaches.
And the correlation ID is the next one, because it's always a correlation IDs and transactions are somehow related, because with correlation ID you have the same problem. The correlation ID is just like anonymous user representation, and you would like to write logs or have audit information with correlation IDs, and if the threads IDs are propagated from the parent to the children, then we have the same correlation ID maybe everywhere. And this solves a lot of problems, because right now we have to hand off the context between thread pools, and with Loom it could become easier. Just interesting thinking, because as you started explaining, the structured concurrency, I immediately got my transactions point of view, which is one of the most common questions. So another thing which really excites me, another question, of course, what I used in the past a lot is completable future. So maybe there was some discussion why the developers just didn't use completable future. Wasn't it possible to implement this with completable future? You know this? Because
but the completable future that's somewhat antithetical to what Loom wants you to do, because completable future is an asynchronous API, right? What you're doing is you're saying do this task, then do that task, then do that task, then do that task.
But you can also wait, right? So you can write synchronous code with completable future.
Yeah, but that's why you get. So if you give something to a task scope, what you get back is a future. Yeah. It's not a completable future, because you don't want to append other operations
you're right.
to it.
And this would be wrong, because then it would imply, you would use an old concept for something new, and everyone would be confused. So this was not the best idea.
I wouldn't use the word old and new, but you use it two different ways.
Loom
wants you to write synchronous code, and completable future wants you to write asynchronous code, and I wouldn't mix them. Yeah. But there's one more thing that I think is important here, and that is, not only do you have these tasks fired off at the same time. So first of all, structured concurrency gives you a strong incentive to basically do the multitasking or concurrency part where you just say, okay, so I want to fire off a few tasks and collect them again in one specific place, namely in that one method where you start the task scope and close it again. So one benefit you get is that it's like this whole where do things happen is limited to just a few methods where they have this task scope. So basically just search for structured task scope and you will immediately find all the places where you even do any kind of concurrency. So that gives you like a more structure in your code, easier to understand, easier to figure out. The other one that I mentioned is it creates this hierarchy also on the running JDK level where threads know their parents and that. The third thing you get is because of this clear relationship between a parent task and the subtasks, and we know that these subtasks are somewhat related, we can decide how to handle errors for them. So you can, like, if you create a structured task scope, what you can do is what you will often do, you will, for example, create a specific one that is called maybe shutdown on success or shutdown on failure, where you say, look, I'm running these 3 subtasks. I only need the first one to complete. So I do shutdown on success, and then the scope, as soon as the first of these returns, will just shut the other 2 down. It depends on how they implement it, how fast that works. But you could think of then maybe, canceling a database transaction or canceling a web call because you're just asking 3 weather services for their forecast. You just want to pick the fastest one. You don't care which one. You just want to have the fastest one. And so the other 2 can immediately cancel their requests. And that way you can continue with the computation as early as possible. Or you do shutdown on failure, where you say, no, all 3 of these need to complete. Like if not all 3 of these complete, I can't go on. So you create a scope that's called the class is specifically called shutdown on success and shutdown on failure. It's inner class of the structured task scope. So you would say try scope equals new structured task scope dot shutdown on success or shutdown on failure. And then that scope would behave as I described. So what you would do is you would say, okay, I want to shut down on the failure, create the scope for that is configured to do that. You run your 3 subtasks, and then what you do is you wait, and then after the wait, you immediately check whether any errors, and then you can handle those errors. So that also means that you can have, not only do you create a parent-child relationship, you also create a sibling relationship where you can say, look, these 3 belong together. I want to treat them in a certain way as a group, where when they all succeed, where I need them all to succeed. So that also means that error handling and retries and all of that should become simpler and collected into the same method that started the scope. So you will probably, that's at least how I want to write that code, is you will have a method that mainly deals with this concurrency. It spins up the new scope, the one that you need, starts all of these tasks, but each task should just be a method. Mm-hmm. Like the thing call the weather service, that's its own method somewhere that only deals with the weather service. It doesn't know anything about stupid virtual threads or structured concurrency. It just does the thing. And then the method that spins them off doesn't care about the business logic. It really just says, okay, so I want to start a scope. I want to call these 3 methods. I want to wait for the error, I want to wait for them to complete. I want to check for the error. I want to compose the result. That one is heavily focused on this concurrency part and how to do errors and how to create results and all of that. And the other methods will only do the business logic. Mm-hmm. So you can you can mix that, but I would recommend not to. And I think that gives you clean code on both sides of this.
The cool story is completely compatible with structure using in my project called boundary control entity. And the boundary would be, the structured task, and the control is just methods with business logic and the weather service. And this would just fit beautifully to this. Mm-hmm. The last thing, because of course we have not enough time to entire Java 19, but this is usual. But what's the last thing which I really like is there will be new executors builder methods to return virtual threads, right? So we get this and thread builder. So there will be new APIs, of course, to get virtual threads back, right?
Yeah. So in this, I did a Project Loom video on the Inside Java newscast on the Java YouTube channel recently, where I basically created, I don't want to call it a hierarchy, but hierarchy makes it sound too strict. But how likely is it that you're going to interact with this or that API? So what you can create, you can just say new thread.ofVirtual and create a new virtual thread by hand. You have a thread builder API that you can use. Those are very low level. I don't think it's very likely that you're going to do that a whole lot. Then you have, as you said, there's a new executor service, which is called, so it's executors.new virtual thread per task executor. Mm-hmm. So that looks somewhat similar to the scope because it creates a new virtual thread for each submit or for each thing that you want to do. The difference is that the virtual thread per task executor doesn't really care about not really. It doesn't care about structure concurrency. All it does, it behaves like a regular thread pool, with the difference it will not pool threads, because pooling only makes sense for expensive resources. Virtual threads aren't. So it will just fire off a new virtual thread for every task you give it to. But otherwise, it behaves like an executor service, meaning it doesn't do any of parent-child relationships, error checking. All of that is up to you. You can use it to fire off background tasks, so you can be done, right? So you can just say, create the new executor service, which creates a virtual thread per task. Here are 10 tasks. I don't even want to wait. I'll just be done. And those are things that you don't want to do with with structure concurrency. So this is another way. This is one step up from the thread and thread builder APIs. And that surely is something that I want to say, like, if you want to deal with bare virtual threads for whatever reason, for example, write a stupid demo that waits on a million threads at the same time, that would be the API to use.
Okay.
And then the next level up is the structure concurrency APIs, which I really hope will be the source of, like, I don't know, I'm making up numbers now, 90, 95, whatever % of virtual threads that we ever create, hopefully go through that API. And it doesn't have to be, but I hope that that's the case. I hope the API will be capable enough to cover all the use cases. Because of the benefits I described earlier, I really think that will be where the sweet spot is. And then still one level up is the level that has nothing to do with you. That is the virtual threads that get created by the web server, which, again, will hopefully be most of them. Well, there can also be most of them if the other already take up 90%. But you know what I'm going at. So
and the web server. The
Yeah.
web server could be Project Helidon. I don't know whether you are aware of them. So it's also an Oracle project. So Project Helidon, they already have support for virtual threads. And they are also implementing microprofile.
Did they officially announce now? Like, because a couple of weeks ago they tweeted that they have an implementation that works with virtual threads, but they didn't like officially announce and support and document and all of that. Did they do that by now?
I'm pretty sure it was an official announcement. I don't think I'm revealing something, but it is like they are working for that. I think they have the first announcement 1 year ago that they are already working on it, and but the Project Helidon and also Quarkus is working on it, and Quarkus is more exciting because Quarkus also love the reactor way of things, which I don't like. So I really enjoy the simple Java way. So so the web servers or cloud native runtimes, next generation, like Quarkus, Micronaut actually, and Helidon. They will support that, and I know that Helidon they are working for a long time already with virtual threads, and which is
so
really
what they did is so what they did is they re-implemented. I'm not, once again, I think it was an experiment, but I'm not sure. So what that is, they re-implemented their server, basically just use virtual threads, and then compared to Netty, and they got, because Netty is like famous for being like really fast, doing NIO, being like super tuned to that, right?
Yeah. And
they got like really close. They got like, and that was that's of course a much simpler implementation.
Yeah, exactly.
Like juggle byte buffers and things. I mean, like Netty juggles the byte buffers. We don't care as Netty users. We're not for us. It doesn't matter, but it matters for the simplicity of and maintainability for the implementation. So one thing that I have to say, like I think there was Quarkus, which was slightly annoying to me. I think it was the pull request that I saw, that somebody implemented this the support, but they were worried about some performance characteristics, so they started to use reflection to break into the virtual thread pool and change some things and offer additional command line flags to, I think, once again, I don't want to say it's 100% sure, but I think it was Quarkus. I should probably look that up. And so what I found annoying about this is, so first of all, it's great that these projects support Loom now. That's really cool.
But if you're unsure, we should blame the Spring guys. They are larger, so I say.
Maybe, yeah. So, just by chance. So look, so let's not blame anybody specific. Let's just single out that pull request, whoever opened it and whatever project that was in. And I know you have like you're influential, Adam. So I'm hoping that all the other maintainers of all the other Micronaut and whatever Spark web micro framework, that all those guys are listening. So please, let's not go overboard with the premature optimization here. Loom is like, this is the first preview of Loom, right? So the chance that people are going to use this in production next week is not very high. So let's stick to just implementing support for virtual threads in the basic level, which means probably flip a switch and just get virtual threads. And then let's give the people time to try it out. Let's give the JDK people time to check into virtual threads more and be sure that everything is tight. Let's just gather more experience together before we start realizing where there might be corner cases and how we can fix them.
But I would say if Quarkus they are really obsessed, and Helidon as well, about performance. So both are crazy about performance.
Yeah.
But if they have the insight already, they can give you feedback. And I would say such a pull request, I mean, could be valuable, right, for the JDK developers, because they see, okay, now we have some problem here, right?
Yeah, but do they? Because there is no benchmark attached to that assumption that might be a problem. It says that we realized. So there's no big data. No, I'm not talking about big data. I mean, like, there's no data to back that up. There is no actual user reports.
So it was not useful. So they put this pull request was not useful.
So, No. So the pull request did implement virtual thread support in that web framework. So that part was 100% useful. That was great. Okay. But it also immediately came with this like questionable performance specifically, which was very annoying to me, is because at least one of those flags that they created is already offered by the JDK itself, and that is how large is the thread pool that runs your virtual threads. You can already configure this. You can give it a min size and a max size, because there's a certain situation where it has to grow and shrink. Mm-hmm. That was already there. So they re-implement something that was already there by using reflection to break into an internal API. And that means that you once again start to get to this issue of we're making internal updates. Now something breaks externally. I don't mind that they're going performance optimizing. I mind it.
In such a situation, I would just use the Sun misc Unsafe class. It works perfectly, right?
Exactly. So it feels like it's like, can we just like, I didn't care, so maybe I should have clarified that. It's okay that they do performance optimization, but please, can we not break into the internal API before it's even released? Can we not just at least have like a one release cycle? Let's say the JDK 19 release cycle, for example, where we like gather data and we figure out whether there is actually a problem, and if there is a problem, who can fix that better before we go hacking? That fell. I don't know. Like I didn't enjoy that part very much.
It really depends on the tone of the pull request, right? Because if the external developer was maybe also a motivated young developer and say, okay, cool, I can optimize something and give feedback to Oracle, is really excited. This is one thing. But if they wrote you back, stupid Oracle, you have no idea about scalability and you should do this. This is a different situation, and it can absolutely happen that you actually didn't thought about all the flags in JDK, so you implemented something which is not usable, maybe, right? But it's really good that they did something and contributed back, right? So I mean,
so it's very important. I mentioned the word annoying on purpose. I meant, like, I don't want to undermine the pull request. The pull request as a whole, it's great. Like, it does something very important. It offers support. I just looked it up. It's a pull request, by the way. I can give you a number on Quarkus. It's 24942.
Okay.
So 24942, that's the number of the pull request on Quarkus. And it's a great pull request. It says, like, look, JDK 19 is not even out. Loom is just a preview. We already support that. For people who right now use early access builds of Loom, can activate virtual threads and then can use Quarkus. I'm not sure whether this is already released, or at least like build Quarkus themselves. And that's amazing, right? So like I'm super on board with that. That's great that we get this early. Just like the part that I find annoying. Once again, annoying doesn't mean I get aggravated. It's just like, did we really have to do this? Did we really have to start with also immediately starting to hack something? But again, I'm just saying. But
the Quarkus guy is hacking all the time. This is the old extension mode in this hacking. So they're optimizing the performance whatever they can. But the Helidons are not better. I had a chat already on the podcast, how Helidon is, they're obsessed about performance. But I got your point. I will put it in the show notes. But I'm really glad.
We don't have to overemphasize it either. So let's just stick with, it's great that Quarkus it's already merged, that they already support virtual threads, and other web frameworks are sure, or web servers are sure to follow. And I think that's very important, because it means that users can try. Because as I said, like we talked about this, like who is going to create your virtual threads and how. And I think many virtual threads will just be created by you configuring, for example, Quarkus or whatever you're using, or Helidon or Spring. Not Spring. I think not Spring is on control of the threads. But anyway, Spring Boot maybe. So you're configuring your server with which kinds of threads you want. And that should take care of much of that. So ideally, I don't think there's lots of reasons to go with thread builder of virtual whatever. I don't know, like that's very low level, right? So ideally, it's web server. Next, use structured concurrency. Next, use the virtual thread executor, and then the other ones is very low level.
Yeah, and don't annoy Nikolai with pull requests, right?
Yeah, or I drag you on Adam's podcast.
Yeah, exactly. So now we covered, the 10% of Java 19 features, which was works as expected. Where people can find you on the internet? Your classic answer.
Yeah. So I'm Nipa FX. So it's Nikolai Parlok and like FX like Java FX. So Nipa FX on Twitter, on GitHub, on Twitch, on YouTube. But what I also do is I work for Oracle as a Java developer developer advocate. So on the Java platform group at Oracle. Wow, that was hard. Anyway, and what I'm doing there is, for example, I'm creating the Inside Java newscast, which you can find on the Java YouTube channel. Now, if you go to YouTube and search for Java, you will not find it for reasons that are beyond us. I think it's Google. No, seriously, I don't know what the reason is. So go to youtube.com/Java. You will find the Inside Java newscast there. You will find the Jeb Cafe, which is something that Jose Pomar does. I think he has also something on virtual threads. He did something a couple of weeks ago. I think there's another one coming up, or it was even just released. You will find Billy Corando, my colleague. He does these YouTube shorts, and you can also find him on Twitter where he does his Sip of Java. So the Sip of Java also appears on YouTube. So you can find me under NipaFX, and then also go to youtube.com/Java or go to dev.java. Or by the way, if you're interested in all this, like this was all just advertisement. Now, a serious tip: if you're interested in how these things develop, and you want to stay close to that, go to inside.java. It's also a resource that we created. Well, I don't want to say we. It's mostly just my colleague David Delabessi and Chad Aramura. They're like it's great. Like David maintains that thing like crazy. So it basically pulls like there is a new JEP. There was an interesting mail on the mailing list. There's a good blog post by somebody from the Java platform group at Oracle over there. So it pulls all the most important resources on this developing stuff. So it's really inside Java. It looks at what is going on in the development phase. And you will also find it aggregates also the newscast and the Jeb cafes. So that's a one-stop. So that's a great stop.
This is a perfect stop. I'm looking at this right now, and this is very minimalistic with lots of information. No ads, nothing. It's just a link like J-shell, the Java REPL, mitigate the relocation degradation. So there's like a newscast. So there's like it was how it's called Java blogs back then. Remember that 15 years ago? But this was more noisy than this.
Dude, 15 years ago I was like
in the kindergarten.
Young. Let's just say young, yeah. No, well, not that young. But there's also, by the way, for all of you people who are not that young.
I was also young. I was very young. I remember I couldn't read, but I say Java blogs. This is what I know. I was very young. This was like...
My mom taught me that,
yeah.
So it's there's the RSS feed too. So that's pretty great. So that's like very easy to keep up with everything. So
thank you. It was a great conversation. Make me think again. And I'm already looking forward to cover the remaining 20 Java 19 topics.
Because to go back to Crete, to the beginning of the episode, I did claim that JDK 90 was like the most exciting release in years, and probably for years to come. And so we just talked about Loom, and I want to defend that claim with more amazing stuff next time we meet.
I'm only afraid that we won't cover all the features until before Java 20 comes out. This can happen to us,
Look, like let's say the end of the year. I think we can manage by the end of the year.
Okay, perfect. See you then. Bye.
See you.